In Pandas, we can use read Excel function to read an Excel file into a data frame. Now, let's import Pandas and datetime modules. From read CSV or read Excel function, the default value of keep default NA is true. It means that Pandas will automatically convert all empty cells and NA cells in the worksheet to a NaN. NaN is used to denote a missing value in Pandas. First, we upload the module 10 Excel to the platform. Then, we type df equal pd.read Excel module 10.excel to the platform. Here, remember that the keep default NA is set to be true. So that's why you should be able to see some NaN value in the table. So in case you want to keep the original NA, you can set keep default NA as false to tell Pandas not to do the conversion. One exception is that hash NA will still convert to NaN. Now, you should be able to see the original NA. If an Excel file has more than one sheet, we can indicate the worksheet that we want to import by putting the name of the worksheet as the second parameter. Here, we type IPO, and you run it. You should be able to see that now you're going to know another set of data. Pandas autofolds columns and rows of a data frame. If we want all columns and rows to be displayed, we need to use the set option function. Okay, so let's type pd.setOption display max columns. None. It means that you are going to let Pandas to show all the columns in the data frame. Then we copy it and we paste it, but change columns to rows. It means that you're going to let Pandas to show all the rows. When you run df, you should be able to see that now we are able to see all the rows. But sometimes it's quite confusing. So in case you don't want all the rows to be displayed, we can set the second parameter back to 10. And then you can see that now we can only see the top 5 and then the bottom 5. The first step of data management is to have a basic understanding of our dataset. Info is a good start for data management as it provides us with the number of columns, the name of columns, the number of rows for each column, and the type of columns. Here you can see the 13 columns and also the corresponding observation in each column. Now I'm going to introduce another function, shape. Shape provides us the shape of your dataset, whether the first number is the number of rows and the second number is the number of columns. Now you know that our data frame is a data frame with 280 rows times 13 columns. It is common that a raw dataset has duplicate records. For example, clients may accidentally make multiple requests on an item due to the network problem. We can actually use job duplicates to help us to drop out duplicate records. Let's type df equal df.job duplicates. After we run it, you should be able to see that our rows is down from 280 to 278. It means that we actually drop out 2 rows. A good practice in data analytics is to set variables in column and observation or records in rows. If our raw data set is not in this setting, we can use t to transpose the whole function. So here we type df.t.shape. And now you should be able to see that we actually transpose the shape. Now it becomes a data frame with 13 rows and 278 columns. We can use a Boolean filter to filter rows that meet certain criteria. We can actually use this method to select rows that we are looking for. For example, in case you are looking for an observation with nil in the column name, you can type in this way. And if you run it, you should be able to see all the information for this observation with nil in the column name. So let's see. We want to know about all the observation with listing price less than 10. Then we can type in this way with the df, and then you type the column name, and the requirement is that less than 10. After you run it, you should be able to see all the observation with listing price less than 10. There are several ways for us to modify a value of a specific record in the data frame. So now, our goal is to replace the market cap for the rows with code 08496.hk with 0.22 to 0.26. First, we want to take a look at the original value of the market cap for this observation. Now you should be able to see that it's now NAN. And we start to type the code. So df.locate and df code. And here we have two equal sign equal to 08496.hk. It means we are going to locate this observation. And then we are going to return the index. And we are looking for the column of market cap. And we are going to replace it by 0.22 to 0.26. Now done. We can actually break down the code in the following sections. First, selecting. We apply the Boolean filter to assign a value of true to target rows and a value of false for other rows. So here, df code equal sign 08496.hk are actually referring to this selecting process. Then we're going to find its corresponding index. We use the index method to get the indexes of the target rows. So we type .index. Then we are going to accessing the specific record. We use locate method to access the target record. The usage of locate function is locate row index and then column name. And our column name is market cap. Lastly, we are going to assign new value. So we use the assign function, which is equal sign, to assign new value 0.22 to 0.26 to the market cap for the observation with code 08496.hk. If we know the index of a specific record, our task of modification would be much easier. For example, if you know that the record has an index of 227, you just type 227 here, and you should be able to do the modification. If every record has a unique value in a specific column, we can also set this column as the index for the data frame to make our modification easier, because sometimes you may not know about the index number. To do this, we can use the setIndex function. We set index as code. Because we know about the code, right? Then you can actually use the code as the index. So here, we type 08496.hk and then follow the same as we do before, and you should be able to do the modification. Let's do some examples. If you want to change the date of the stock with code 01740.hk to 16 January 2020, we can type the following code. Here, we use the datetime library. When we use the df.locate to show the information of this record, you should be able to see that the date changed to 16 January 2020. Next, if we want to change the code of the stock with the current code 00210.hk to 02110.hk, we can type the following codes. When we call the observation using the O code, which is 00210.hk, and run it, you should be able to see that there's an error. Why? Because the code already changed to the new one. So when we type 21110, you should be able to find the new record. So to reset the index of rows to integers 0, 1, 2, 3, we can use reset index method. As our data frame still contains the column, so we set job equal to true to not add back the code index into our data frame. So here we can type df equal df dot reset index job true. You can see that now the index go back to 0, 1, 2, 3, 4, 5, 6. We can use the job NA method to drop records with at least one missing value. If we want to drop all records with a missing value in any column, we can use the job NA function. Now we know that the data frame originally has 278 rows, 13 columns. Then we use df equal df dot drop NA code. You can see that we actually drop out some rows. In case we only want to drop all records with a missing value in a specific column, we can actually type the parameter using the column name. But before that, how about we just get back our original data frame? Then we go back to our cell, and then we type df equal df dot drop NA subset equal name. When we use the shape function, you should be able to see that there are some rows are dropped out, but the number is actually higher than before because only observation with missing value in a specific column is dropped out. We can delete a column using drop method with the column name. If we want to drop a column, we need to set access equal to 1 as a parameter. So here, let's type df equal df dot drop, and here we focus on the column last price and asset equal to 1. We want to drop out the column last price. And when we run the code, you should be able to see that now the column last price is dropped out. We can use .drop method to remove a specific row with the index. If we only know the value of a column of a specific row, but not its index label, we can set this column as the index label first and then apply drop function. So here, we know that the original data frame has 275 rows and 12 columns. Then we set the index as name. Next, you are going to drop out observation with index name with the following 3 names. So when we run the code, you should be able to see that now our observation is down from 275 to 272. It means that we already dropped out these 3 records. Okay, so that's all for module 10. Thank you for watching today. And in case you want to do some practice, you can try to do the following exercise. So thank you again for watching. Looking forward to see you again in the next video. Have a good day. Bye.